Explain the cyclical variations in plasma hormone levels that occur during the menstrual cycle. Describe how these hormones regulate the ovarian and uterine changes that occur during this cycle. So we'll talk about ova and their development, the menstrual cycle, which involves two other cycles, which we'll describe, and then the long-term hormonal regulation of female reproductive function. Okay, so the female reproductive system is very different from the male. There are a lot of, structural analogies, but the cyclical changes are very different. In the female, we also have to be preparing the uterus for the actual gestation. Males don't have to worry about that. So here we have the cyclical changes that are seen in the gonads, the ovaries, but we're also looking at what the changes that are taking place in the uterine lining as well. So they're kind of two separate cycles involved in the female reproductive physiology. So the cyclical changes are called the menstrual cycle. They're revolving around a very restricted window of fertility that's called ovulation. This is when a woman is most fertile. And then there's another structural or functional difference here is that women are thought to have an established pool of gametes at birth. So women are thought to be born with all the eggs that they will ever be able to fertilize, and that pool can never be replenished the way that it is for males. Okay, and we'll kind of describe that in more detail when we get to that. But I do want to point out now that, again, there's a lot of emerging literature that's suggesting that women have stem cells that are arrested, and there are certain hormones, certain triggers that can be used to kind of encourage fertility later on in life. So you guys may experience or come in contact with different emerging literature that suggest otherwise. But as far as now, that is what the school of thought is, that women are born with about 400 ovum or so, and that is the limit of her pool. So let's go on here to describe what happens in terms of the anatomy in women, in females. So there's a follicle that's developing every month inside the ovary. It starts as a primordial follicle, which basically is comprised of two structures. There's a granulosa cell, which is very similar in structure and function to the Sertoli cell in males. And I'll keep on making that analogy between the granulosa cell in terms of the hormones that it releases. It's very similar, analogous to the Sertoli cell. And then the second part of that follicle is the actual oocyte, which is the ovum, right? Those are synonymous. So we have this follicle that's developing, which is comprised of the oocyte inside. And as it begins to develop, it's now surrounded by this granulosa cell, which is pretty much supporting its development, very similar to the way that Sertoli cells support the development of spermatocytes. Now, Okay, so the granulosa cell continues to support the developing ovum inside the follicle. It's going to be the target of hormones estrogen as well as FSH, and it's going to secrete messengers, chemical messengers in response to these hormones. It's also going to secrete inhibin, again, just like the Sertoli cells. And the inhibin is going to have a negative feedback onto the anterior pituitary, or the FSH production from the anterior pituitary. It's going to be nourished via gap junctions that are, helping bring in oxygen and nutrients to sustain the growth and development of the follicle. And it's also going to secrete estrogen. So this is going to be the estrogen that does several things. Estrogen is going to help with the growth of the follicle, but it's also going to be having an effect somewhere else in the uterus. And we'll talk about that when we get to the uterine cycle. Okay, but this is the function of the estrogen that's being secreted here in the follicle by the granulosa cell. So here's a table that compares the Sertoli cells and their functions to the granulosa cells, and you can see a lot of differences. So the fluid that's secreted into the lumen to help with the support of sperm and the transport of sperm, there's also an analogous fluid that's called the antral fluid that creates the antrum in the mature Graafian follicle. The Sertoli cell is also providing the nutrients that helps the sperm to develop into a mature spermatocyte, and then the granulosa cell is providing the nutrients as well that help the oocyte to develop via those gap junctions. They both secrete inhibin, they both secrete estrogen or testosterone, and they're both kind of just supporting the healthy development of the gamete, of the spermatocyte or the oocyte. Okay, let's look at the process of oogenesis. So oogenesis is the division of the oogonia to provide ova. Ova is going to be the plural term. Ovum is going to be the singular term. That's one ovum being ovulated every monthly cycle. So females are, again, thought to be born with a fixed number of oogonia, and these are arrested in their first meiotic division by the time of birth for that fetus. So when a woman is born, she's born with a fixed number of oogonia that are arrested in their primary meiotic development. And this is, again, in contrast to males. So remember we said that the spermatogonia, there was a division into two. One of them would stick around to continually divide to provide more spermatogonia, and one of them would continue on to differentiate into a mature spermatocyte. Here we don't have that, right? All we see is that there are a fixed number of primary oocytes that are all sent to become fully matured ovum if fertilization takes place, okay? So we have that first meiotic division arrested during fetal life, and then the second meiotic division, only takes place after meiosis, after fertilization. So every month when a woman ovulates, one of those ovum continue on to complete the first meiotic division. So that is what ovulation is, the completion of the first meiotic division, the production of a secondary oocyte, and then a polar body, which eventually disappears. And then if this ovum is fertilized, only then will the second meiosis complete and the production of the mature ovum be completed. So this is really showing the value of ovum. And there's this saying that spermatocytes are cheap and ovum are expensive. And there's certainly that, that kind of physiologic correlation here, because we see that an ovum is only completed to its mature state if fertilization takes place. So if there's an embryo, and so an ovum is pretty much never going to complete its meiosis until it's going to become an embryo. So it's a lot more valuable than spermatocytes that are always becoming mature in a large amount, in a large quantity. So let's look at the menstrual cycle. So these are the repeated changes that are seen, again, both in the ovary and the uterus over time. It includes two subcycles, the ovarian cycle, which has the follicular phase, and the luteal phase, and then the uterine cycle, which has 3 different phases. It's caused by the changes of estrogen and progesterone concentrations in the plasma at different times that are stimulated because of the changes in the hypothalamus and the anterior pituitary. So again, very much like what we saw in males, the reproductive system is tying in with the endocrine system in that GnRH, LH, and FSH are pretty much controlling the release of these hormones, estrogen and progesterone. So the ovarian cycle has 2 phases. The follicular phase is the first 14 days. This is from the time of menstruation all the way to ovulation, which happens at around day 14. And this is where that follicle is developing to become a mature Graafian follicle. After it has become a mature Graafian follicle, because of the nourishment of the estrogen being secreted from the granulosa cell, then it's going to rupture out from this, this follicle here, and the oocyte itself will continue on to become fertilized, hopefully. The second 14 days is called the luteal phase, and this is from the time of ovulation, which is that rupturing, all the way to before menstruation. And what's happening here, the overall events here in the second 14 days is that the oocyte has now ruptured out. The rest of the follicle becomes what's called the corpus luteum. We'll describe what that is and its role a little bit further down, but the corpus luteum is either going to continue on to help sustain the pregnancy, or it's going to regress and trigger the sloughing off of the uterine cycle, which is the menstrual flow, okay? So the first 14 days is the building up of the follicle, and the second 14 days is hopefully the preparation of the uterus if this follicle, if this ovum that has been ruptured should be fertilized. The second half of the ovarian cycle is called the follicular phase. Oh, I'm sorry, this is the first half. This is the follicular phase. So we're going to go into this in a bit more detail here. So we've got estrogen and FSH that's coming from the anterior pituitary, estrogen coming from the granulosa cell. These are going to stimulate the development and the growth of the follicle. Now, a few follicles will develop as primordial follicles, but only one follicle will become mature each month. It's going to grow, it's going to acquire certain features, the zona pellucida, the antrum begins to form. The antrum is this fluid-filled sac here. It's also going to develop the corona radiata, which is the spike that's kind of left around the ovum, the kind of pinching off of the granulosa cell for it to prepare to rupture out. And when it develops these features, it is then it's then called a Graafian follicle because these are the features of a mature follicle that's preparing to rupture. And again, only one of the follicles gets to this final mature state. And then we have ovulation. The triggers for the follicular phase are going to be GnRH coming from the hypothalamus, which then triggers LH surge from the anterior pituitary, and that LH surge is what triggers the rupturing off of that ovum and then the leaving behind of the corpus luteum, which is what the rest of the follicle actually becomes. Okay, let's look at the luteal phase. So the second 14 days here of the ovarian cycle. So once we have the ruptured follicle, the rest of the follicle becomes the corpus luteum. Corpus luteum translates to yellow body, and it begins to secrete the estrogen and progesterone that is going to help sustain, hopefully sustain the pregnancy if this fertilized ovum should be implanted. If it gets to 10 days and there's no fertilized ovum, then it's going to automatically start to degenerate. This is a process called luteolysis, or lysis of the luteum, lysis of the yellow body. This is where there's decreased estrogen and decreased progesterone because there's no fertilization. And this is where we trigger the degradation of this yellow body, and we trigger the flow of menstruation because there's no fertilization. That took place. This is the end of the luteal phase and then the beginning of a new cycle, starting with the beginning of the menstrual phase. If the oocyte is fertilized, this degeneration does not take place, and the corpus luteum actually sticks around and begins to create the hormones that are important for sustaining the first part of that pregnancy until the placenta can take over the role of hormone production. Okay. So here is an overview of the steps of the ovarian cycle. Actually, let me pause here. I think I see a question. Okay, so I got a really interesting question. Thanks for asking this question. So can more than one ovum become mature in the same month? How does the cycle differ? So that's an excellent question. You can actually have two ovum being ovulated. Usually the ovaries will take turns. So you'll ovulate an ovum from one ovary on one side and then from the other ovum on the other monthly cycle. But you can have two things. You can have ovulation of more than one Graafian follicle. You can have ovulation from both ovaries in 1 month. Although that's not common, you can have these things. You also can have one fertilized ovum splitting into two. So this is what we know as identical twins. Whereas if you rupture two separate ovum and both are fertilized, that's what typically produces fraternal or non-identical twins. okay? So you can have a couple different variations here, but typically standard, the most common occurrence of events is you rupture one ovum from one ovary, the next month you rupture one ovum from the other ovary. Alrighty. Okay, let's hang on here, see if there's any more questions. Okay. So here is an overview of the sequence of cyclical events that are the ovarian cycle. So these are the sequence of events that are happening to the follicle. So we start with the primordial follicle. They all, let's say all four of them begin to develop, but eventually only one will proceed to become the Graafian follicle, and all of the others will eventually regress or disappear. The features that are standard of a Graafian follicle are the development of the zona pellucida. So the zona pellucida is kind of this area around the ovum. It's kind of helping to separate the granulosa cell from the ovum itself. We see the pinching off happening here, which creates the cumulus euphorus, which is this kind of island here between the ovum and the rest of the follicle, which again is indicating the pinching off. We also see the development of the antrum. So this fluid-filled sac starts to develop, which is hinting to the separation of the rest of the follicle and the pinching off of the oocyte, again, in preparation for rupturing out of this ovum to become fertilized. So these are the features that we see that make this specific follicle a mature follicle or a Graafian follicle. And this is typically what your reproductive endocrinologist may be looking for if he's trying to extract mature follicles. Let's say there's some type of reproductive procedure that's happening where they're trying to extract mature follicles. These are the features that they're going to be looking for to determine which of these follicles is going to be mature, is going to progress on to become the Graafian follicle. And usually, I'll add here, usually they will give some type of ovulation stimulating hormone that would encourage more of these primordial follicles to make it to their Graafian stage. But typically only one will make it to the Graafian stage. But we can induce outside hormones that will artificially allow a woman to mature more than one of her primordial follicles to their Graafian stage. Okay. And then the second half of the cycle, the second 14 days after ovulation, we see that the rest of the follicle, what's left behind, becomes the corpus luteum. And if that lasts for 10 days, then it will begin to degenerate. It becomes what's called the corpus albicans. And then it triggers the decrease of the hormone levels and the menstrual flow, which is menstruation, right? The sloughing off of the